I want to show a project I've been working on with my friend Justin. It is a jack-o'-lantern with a dozen eyes that look all around. I'll include a link to the video where we first saw it, and I'll also include a link of the Arduino Sketch. What you need for this is a pumpkin. I'm using a foam craft pumpkin. Mine happened to split along the seam. This was not on purpose, but it turned out to be pretty useful because it allows me to work on the inside without any issues. A dozen eyeballs, and you need a pipe for it to fit in. I'm using 1.25 inches. I took the eyeballs with me to the hardware store and picked out pipe that is just a little bit bigger. Stiff wire, I used hangers, unbent hanger, and cut it into about 1.25 inch pieces. Servos, I'm using SG90 servos I got on Amazon. A bit of wood, I'm using this 1/4 inch square stock. This is picture hanging wire, and it's 20 gauge single, not stranded, it's solid, 20 gauge solid. An Arduino Uno, and various connecting wires. These are the type of project wires that for proto boards. These happen to have pins on both ends. So the first thing we had to do was figure out our placement after we knew the size of our pipe. So I cut a segment of pipe about yay length and then used it to mark holes on the craft pumpkin. And then I carved it out, and then using the same piece of pipe, some of these places I had to carve out a little bit of foam from behind. And the way I knew where I had to do that is I would place the pipe inside and then see how flush I could get this to sit. Still not perfect, but you'll see how I compensate for that. Each of these eyeballs have to have a hole drilled exactly perpendicular top and bottom. And the way I did that is I took a piece of pipe and I marked with a straight edge in the middle, and I'd put a dot on one seam, line that dot up with the mark, hold the eyeball. I had a bit of cardboard in here to hold it at the right height, and then with the dot on the other end, made the mark there. And then using a Dremel, drilled out a little hole, to which we cut a segment of wire to stick it through. Oh, in order to get the wire to stay on the PVC, cut a notch on the PVC. Let me show you how I did that. Over here at my vise, I have a piece of wood that I cut the edges to be able to just accept the pipe. And then I took a Sawzall, which had the standard, I guess that's a wood blade, which was just thick enough for the wire, so I carefully cut my notch front to back. Once we get the eyeball threaded with the wire, we then stick the wire down in the groove and apply a little dab of hot glue on each side. So once you glue that in place, you now know the axis of your eye. So we took each of the eyeballs and centered them with a piece of wood that we cut. We also pre-drilled a little hole in one end. So we glued that to the back of the eyeball with it centered, and that hole is parallel to the axle. So, piece of PVC, as you can see, the eyeball, little dot of glue holding that wire in place, that piece of wood glued to the center on the back, servo glued to the side. Make sure it has clearance for the servo arm to move and not hit. So you see I have the screw just past the back end of that. And also make sure the axle or the point of rotation is parallel with your wire, because what you want to do is have the servo move back and forth to push and pull that piece of wood, which will give you some eye movement. I know it doesn't look like a lot, but that can be adjusted. You can shorten this rod. You could shorten this whole collar, make that rod shorter. You'll get more movement out of it. But as we found, this was plenty to have a nice, subtle, creepy look. So, we build 12 of these. Then we laid them all out, and we connected it to the Arduino after loading the code to verify that all 12 servos worked, which I really should have tested before I assembled all the chassis. But we got lucky. I mean, they're cheap servos. One or two are bound to fail when you buy 30 at a time. Then we start gluing, and this is how I do this. As you can see, I've got several in there, and the orientation of the servos keep changing because I don't want all the eyeballs to look left and right. Some of them move up and down, and some are at various angles. Take one of the assemblies and place it, just hand fit it, place it where I want it, and then I'm going to verify that it is not going to turn at the same angle as the ones to the immediate left or right of it. I want everything to be a little bit off from each other. I'm going to hold this here. Now, I'm going to take my hot glue gun, which has heavy-duty glue sticks in it. They're the ones that are kind of yellowish. Tack about a quarter turn of the circle, and then I hold it in place for a few seconds, flip it over, and verify that my eyeball is centered and not rubbing on any of the edges of the hole. I have a blower fan and a switch set up. Pardon me. I have a blower fan and a switch set up. The blower fan came out of a yard inflatable. So what I do is I turn that on once I like the placement, and then I just hold this against the airstream coming out of the blower to help cool the hot glue quickly. Once that's cooled sufficient, I, still holding this in place, will check movement to make sure I didn't get any glue on the eyeball. And then I repeat, hot glue around the opposite edge. I'll show you just about how much I'm doing. Right in here, you can see about a quarter. I hope you can see it. I'm sorry, I don't have a cameraman this weekend. So while manipulating the camera and everything, I accidentally rolled the assembly, and I did get some glue on the eye, which is, it's bound to happen. You may recognize these. These come in those Pumpkin Masters pumpkin carving kits. That's what I used to cut all these holes. So hand cut them all. I did trim the back ends with a Dremel. I had a ball grinding stone, and that's where I trimmed away the foam that was in the way. So, but I want to show you, this carving tool is actually quite good for breaking the glue seam if you get any on the eyeball. It'll fit right in between the eye and the pumpkin, and it'll even fit down inside the PVC pipe. So it keeps it centered, helps you not cut the pumpkin anymore, and as you can see, it digs out the glue pretty nicely. Yes, this is my second pumpkin I've done. The pumpkin you saw at the beginning of the video was for my friend Justin. He's going to be making a steampunk slash clockwork kind of pumpkin. So he pre-painted his pumpkin copper with, or yeah, I guess like an old metal color, and did some gold flake. And his is already done, so that's what's at the beginning of the video. And I will show you this one at the end of this video. Yep, so that's good. Last one. All of the eyeballs are in place. He looks so happy. And you can see the servos in all the different directions. Now, I need to make up wiring harnesses for 12 servos and power. I took at each servo, connected 3 wires into the servo lead. And I copy the brown and red on every servo, and then I gave the signal lead a different color, just because I could. But I want to show you what I'm doing next to make plugging and unplugging easy. Because these are all individual wires, I've got my hot glue gun again, and I'm going to take the 3 individual wires from the proto board wiring, and I'm going to run a bead of glue across it and let that cool for each set. And I'm not gluing the wire to the connector, I'm just gluing the 3 loose wires together to make a connector. So I've got all the power wires together, wired up. Just need to solder these. I've put in a length of wire for me to attach to a power source, such as a battery tray or a 6-volt power supply. I also have a red and black lead, which do not go to servos. These are going to be for the Arduino. By the way, if you're not comfortable soldering, you can always use wire nuts to cap these together or tape them together. Just make sure you've got a good connection. I know soldering's not for everybody. One of the suggestions by the person who created this project, he used a proto board and ran a power rail through there and just used the same plug-in pins that I'm going to be using to plug into the Arduino. So he just made a board with common power connections for everything to connect to. I've got each of the servo wires coming to their connectors. I split off the 12 signal wires and their pins, and then the power bundles come together. Here's power for the Arduino, and then my spare piece of wire that's going to go to a battery box. So everything is going to connect to this. I'm going to include a diagram right now. Because I didn't have the ability to hold this camera in a position that would make sense as I'm connecting everything up. So that diagram is how I connected everything up. Again, the diagram was provided by the original creator of this project. One of the things I discovered is either these servos draw a lot more current than they're spec'd out to be, or I have really crummy batteries. I could not get this to work on a stable function off of batteries. So I grabbed my 6-volt power supply that I use for my Raven, and now it seems to be working fine. So I've got everything hooked up on the Arduino. But here's the back of the pumpkin. And the movements are clustered in different groups and randomized. So the amount of movement is random, and there's a time delay between moving the groups. But here's what it looks like from the front. I may give it less time between the eye movements so it looks around more often, but I was afraid that might look too busy. And Justin's, which you see at the beginning of the video, his is set to a little bit faster than mine. I've slowed or lengthened the delay between eye movements, and I might like it a little bit faster, so I'll try it. Oh, and also, as you could see in the front of in the front of this video, I had his backlit, so I'll show you what that looks like. Now, I don't have a back on the pumpkin, and this is just a spotlight shining in at the back of it. But it shows you it could be lit from behind or from inside. You could even do different colors if you're so inclined. Maybe I should turn off the light. So as it's been running, I've heard one of my servos bottom out and sounds like it's broken a gear. Like I said, when you buy them in packs of 30, you expect one to fail. But it's still running. It's just, it overshoots. In fact, it's this eye right here. But still seems to be running. So let's try a different color. First was yellow, green, now. Wow, this red looks more orange. If I put my hand in front of the light and dim it down, it gets a little more red. So, thank you for joining me on building this project, and I hope you attempt this yourself. I'd love to see what other people make. Thanks for watching.